Great. Welcome, everyone. My name is Elizabeth Wentz, and I am one of the enrollment specialists here at the Data Incubator. We are a fellowship, scholarship, and placement company, and today we have a great session for you with Nicholas Dela Fuente, who is one of our instructors, and he will be going through the fundamentals of building a data pipeline. Just to give you a sense of where we're going today with the agenda, we are going to do a quick staff introduction and then a little bit of a program overview. And then I'll hand it off to Nick, who will lead us through our discussion. And then at the end, we'll have a little bit of time for questions. A few housekeeping items just off the bat. Today's session is scheduled to be 1 hour, including questions. All participants are muted, and this is to help us get to as many questions as possible. If you do have a question, feel free to enter it in the Q&A box. We're using the chat box for general announcements and resources, so avoid using the chat box to ask questions. If you do have questions, again, put them in the Q&A box. If there's anything that you have a question about that you'd like to discuss outside of this session, you can always email us at admissions@thedataincubator.com. And we will also send out a recording of this session to all registered attendees about 72 hours after we conclude. So with that, I want to invite Nick to come off mute and introduce himself.
Hey everybody, how's it going? I am Nick, the data engineer currently at TDI. I am going to be walking you guys through a pipeline introduction today, sort of giving you guys the fundamentals of what it's like to deal with a pipeline, what a pipeline even means, and stuff along those. But we'll be talking about that later. A personal introduction for who I am is I studied physics and economics at Arizona State University, and a lot of my research in the past has primarily been dealing with sort of physics-oriented stuff. So I worked as a financial analyst intern at Hyperloop. That's where I got my start in data, and then I transitioned over to Mayo Clinic, where I dealt with X-ray distributions and CT scans, sort of classifying biominerals based off of patient data as well as CT scans. So that's where I really got my start in data science. And data engineering. And then after that, I started to pursue data engineering a bit more strongly because I enjoyed it a bit more. And I transitioned over to teaching data engineering at Lambda and doing some data engineering stuff as well in some different departments with some different companies as well. And now I'm currently teaching at Pragmatic, introducing data engineering concepts to people like you. So a lot in my spare time, I'd like to play guitar, come up with some weird, ridiculous ML models, mess around with different data engineering cloud services that are up and coming. And I tend to do a lot of nature stuff, whether it's rock climbing or hiking. So I look forward to walking you guys through some of this stuff today.
Great, thanks, Nick. So just to start off, let's talk a little bit about the Data Incubator and what we offer. So we focus on training people to become data scientists and data engineers. And, you know, part of the reason that we think this is important is really that data professionals have the ability to work with kind of the latest tools on unstructured and structured data to really add business value. And as you all probably know, this is a big need in the world right now. We work with companies in many different industries, you know, tech, finance, retail, healthcare, and others. And what draws them all together really is that they all have data and they all want to use it to create value for them. So for us, I'm sure you know there are lots of different data training boot camps out there, but for us, one of the things that really makes us unique is that we kind of try and balance these competing models of, on one hand, you can be really fast and efficient as a training program. On the other hand, you can be really maybe slower, but more focusing more on a deeper understanding. And I'm sure you've all had experience with both. I think kind of the slower model, you might remember university, where it's more detailed and a lot of, but you're also investing a lot of time. On the job training might be an example of kind of the faster pace, where you're getting through information really quickly, you're getting into practice really quickly, but you might not have as full of an understanding. And for us, what we try and do is really balance the two. So kind of finding that middle ground for us all. So our program is really fast paced. So you will walk out of the program knowing a lot more about data science or data engineering than you entered with. But it's also based in kind of real world business applications. So you'll get a deeper understanding of that aspect of how to apply this in business than you would get from university. All of our instructors as well have PhDs or masters, and many of them actually completed the program themselves, which is nice. So they really understand how to provide in-depth training that you're looking for. We do have a few programs right now, excuse the formatting. We have 2 full-time options. One is a full-time data science fellowship. The other is a full-time data engineering program. And we also have a part-time data science fellowship. If you're interested, you can always email us at admissions at the data incubator to request more information on part-time on any of these options, if you'd like to know more about them. So just I want to take a little bit of time to talk about some of the similarities of our offerings for all 3 programs. All of our programs are intense. So they're built around kind of using hands-on data focused. In our curriculums are built on using hands-on data. And for both a full-time and part-time program, they're really packed with a lot of information. We also are pretty thorough. Each week you'd be working on a different data tool or approach. And you also, in addition to lectures, are doing hands-on practice. So that's something we really believe in, is kind of fostering this interactive learning environment. So in each program, students work through mini projects each week that focus on the data that you're studying, the data tools you're studying. Our programs are also quite collaborative. We want you as students to work with your colleagues and instructors, and also get the chance to network and connect with our hiring partners. And on that note, our programs are also quite career focused. So we have career coaches to help you succeed in that transition over to a data focused career. You'll learn how to present yourself through career workshops. And you'll have opportunity to work with a #1 resume writing company to get you a polished resume and cover letter during the program. Finally, our programs are also very interactive, as every student in all of our programs has access to a Jupyter server for the duration of the course. So you can follow along in lecture and edit raw code that's being run. And you also receive immediate feedback on your work via our interactive grader. So again, you can always email us at admissions at the Data Incubator if you have more questions, and connect with enrollment counselors like myself to discuss them. So here we have an overview of the full-time data science program. This runs for 8 weeks, and you can see an overview on the side of the curriculum breakdown by week. The expectation here for the full-time program is generally that you're spending about 40 hours per week in class and working on assignments, some combination of that. So that's just something to know. We also have a part-time data science program. This runs for 20 weeks with classes held on Monday and Wednesday from 7 to 9:30 p.m. Eastern Time. You also get office hours each week and are expected to put in about 10 hours per week outside of class. So this is a really nice option if you want to take the data science program, but the full-time commitment feels unrealistic for you at this point. In this part-time program, you get the same curriculum and training as a full-time program, but it's just stretched out over 20 weeks. So you have a little bit more time to process it and balance it with other commitments you might have. The sessions are also live for this and instructor led, so you still get that interaction with your instructor and can ask questions. And finally, we also have the full-time data engineering program, which Nick is a part of. And this is, again, an 8-week cohort. And you can see the curriculum over on the side again. Like the data science full-time program, the expectation is generally you put in about 40 hours in class and working on assignments per week. And if you want a more detailed breakdown of curriculum for any of these programs, again, you can always email admissions. And actually with that, I think I'm handing it over to Nick to start our demonstration. And I will be back a little bit later on.
Hi, everybody. How's it going? So today we are going to be talking about building pipelines, which is both a data science and data engineering centric kind of topic. So let me go ahead and share my screen with you guys and we can walk you through exactly what we're going to be doing right now. Okay, can everybody see my screen? Yeah, I hope so. Okay, cool. So in general, what Nikki is about to send out is going to be a link to a Google Colab where you can take a look at what we're going to be walking through today. Again, some basic pipelining architecture stuff. And she's also going to be sending you a Python, or sorry, in a Jupyter notebook as well. So if you'd like to, you can follow along as well and download the Google Colab notebook to your own Google Colab account. So let's go ahead and get started and discuss what a pipeline is in the first place. So all a pipeline is essentially an automated process that is going to allow us to perform some type of data movement. Really, that's all it is if we can sort of think about a pipeline as moving as a water pipeline, moving water from point A to point B, a data pipeline is the same thing, moving data from point A to point B. Right, so that is what a data pipeline is, and there's often some shared steps in the types of pipeline that we're implementing, the type of data pipeline that we're implementing. These steps involve extract, transform, and load data. And there's a specific term for this. It's called an ETL pipeline, and we'll talk about this in a moment, but let's first talk about why we need pipelines in the first place. As people who deal with data, both data engineers, data scientists, or even data analysts, data is often extracted from a source. It comes from a specific location, and we need to do something with that data in order to make it more curated and usable for anybody down the line who's going to be interacting with this data. So usually this data has to be transformed. Right, and the transformation of this data can take the form of merging data to an API, handling null values, cleaning the data in some type of robust way, or just combining different sources of data. This data is then loaded into another location so that it can be accessed later. And this is sort of hinting to something called an ETL pipeline, which is something that is very common in the pipeline world, in the data engineering, data science world. So in general, when we're interacting with data, pipelines are going to consistently be used to automate and handle the data process, right? It would be kind of annoying if every time we wanted some piece of information, say some financial analyst is trying to get information regarding some financial data, they're not going to need to go directly to the source. And that's where the data scientists and data engineers come in. Data scientists are going to be more specifically oriented on developing a method to get insights from the data that's coming from the source, while a data engineer is going to be developing the sort of processes that get that data to the financial analyst. Both, however, are going to be dealing with some type of pipeline, right? Where the data is coming from the source, handled through a pipeline and then given to a financial analyst or some type of business person. It could even be fueling some type of dashboard. But again, the whole point of a pipeline is moving data from point A to point B. And again, as I mentioned before, these techniques are utilized by both data scientists and data engineers and can be written anywhere from Python to SQL. It doesn't matter what the language is, it's pretty language agnostic. The idea of pipelines has a lot of computing as a lot of computer science topics tend to be. So let's go ahead and talk about the popular pipeline that I've been throwing around, which is an ETL pipeline. An ETL pipeline, which stands for extract, transform, and load, is the most common type of pipeline. And what an ETL pipeline is going to do is it's going to provide us with a list of stages where data is going to be first extracted from a source, and then after being extracted from a source, transformed, and then after being transformed, loaded into some type of auxiliary or secondary data storage source. We're going to go ahead and walk through a very, very basic example of how to utilize a simple database to extract data, perform some transformations, and then load this data into another source. So we're going to be dealing with API calls here. We're going to be dealing with databases, SQLite databases, and we're going to be dealing with some very basic transformation steps. So let's go ahead and get into it. So again, extraction is the first step in an ETL pipeline, and it's going to be extracting the data from some source. In this instance, the source that we're going to be extracting from is an API called OpenNotify. And what the OpenNotify API is going to do is when we make a request to this HTTP api.opennotify.org/astrosjson, when we make a request to this endpoint, we're going to get back a JSON document with a list of information, specifically the number of people in space, as well as the actual people as with their names and the craft that they're associated with. So we can see that Denis Matveev is on the ISS. And there's 10 names we have here in this list of people. So that is the data we're going to be requesting. That's the extraction that's going to be performed. And this is going to just give us a real-time count of the total number of astronauts in space, along with the names of each astronaut. Okay, so to make this request to this API, we're going to go ahead and import the Python library request. Request is going to allow us to make a GET request to this API we have up here. So we're going to go ahead and say response equals request.get. We're going to pass in this URL so we can go ahead and get back this JSON document, and then we're going to go ahead and take a look at the status code. And if you're familiar with network status codes, we can see, or HTTP status codes, we can see here we have a 200, which means a success. Lovely. Now, if we come down to here to taking a look at the different data, we're going to go ahead and grab the data from the response object and convert it into a Python dictionary just by calling this JSON method we have attached to this response object we're getting back. If we go ahead and take a look at what this response object is, we can see it's coming from the request library. Oh, sorry, should be type. You can see it's a request object or response object coming from the request library. And this response object has a JSON method associated. So we can go ahead and convert this JSON we're getting here into something more Python interpretable, a Python dictionary. And this Python dictionary is going to act as a normal Python dictionary, as in we can grab number, which is going to give us 10. We can grab the people list, which is going to give the list of people. And since this is giving back a list, the people key is, we can go ahead and return a value from that list. So we can get the first dictionary in that list from that key people, and then we can even go further with this dictionary and grab the name of that person as well. Lovely. So this brings us to the end of the extraction step, where we've successfully grabbed our data. Now we're going to go ahead and move on to the transformation step, which is going to be transforming that data or gaining some insights from that data that we just extracted. And although one of the primary conversations we'll be having is in regards to ETL pipelines today, we're also going to talk about other types of pipelines that you might see in production as well. So let's go ahead and talk about the transformation step. So let's say we wanted to transform this data so that it can be properly loaded into the relational database, the SQLite database that we have for the load step. Now, this transform step can add a new value to the data. It can keep track of when requests were made. It can count how many astronauts, first names and last names start with a vowel. It can do all sorts of things. And what we're specifically going to be doing today is adding a now value, which is going to be keeping track of when the request was made. Since that information is not present inside of the extraction step, we consider that to be a transformation step. We're also going to be counting how many times, how many astronauts' first names and last names start with an A, or we can do any val as well. We're going to just take an example or take a look at what the A will look like. So we're just going to count the total number of times that, the last name has an A or the first name has an A. Again, something that might be arbitrary now, but again, this is just showing the power of what the transformation step can do, or at least the potential of what happens in the staging step. We can also then go ahead and format the data so it can be properly uploaded to the SQLite database. This might be deconstructing dictionaries, expanding or exploding or expanding list so that they're in proper column or format, and then sort of handling those data changes here so that when we get to the load step, all we have to do is upload that data to our data sink, or our data, our loaded loaded data storage place, right? So we're going to go ahead and just have a transformation that's going to create create new data. So we're going to go ahead and create a now, which is just going to keep track of the current time step when a request was made. Then we're going to go ahead and have a transformation that can grab data from the extraction step. So we're going to go ahead and just grab number in space. We're not going to store the names of each astronaut in space. We can go ahead and see we get back that number here. We're also then going to go ahead and write some of the logic for extracting the total number of first name and last name counts. Now, again, a transformation can grab data from an extraction step, create new data, or it can gain new types of insights. And this is sort of where the data scientists come in. We can gain insights from this extracted data that we have above here. This is a simple one, but I'm sure you can imagine how these can begin to become a little bit more complex. So let's talk about what we're doing here. All we're doing is we're grabbing the first letter after the space, so the beginning of the last name. So we're iterating through that list of people. So if I come up here and I say people in data people. Oh, sorry. I don't want to do that. We want to say just the first instance. We're iterating through people. We can see we have a list. So this for loop is just going to iterate through each person, going from 0, 1, 2, to however long this list is, right? Then we're saying if the beginning character in this name of that person starts with an A, and we're going to go ahead and lower that since it's probably going to be uppercase, to a lowercase value. If that begins with an A, then we're just going to go ahead and count that to yes, this person's name starts with an A. And then going on to the second step, which is counting the last name starts with an A occurrences. We can see we say last name. We're going to go ahead and search using this regular expressions package. And this regular expressions package is going to allow us to look for this expression we have here, which is just going to be a space and character. And then these parentheses are indicating a grouping. So we're going to grab that group from that search result, and we're searching this pattern in this string, in this name string. And since it's looking for a space and a word, we're going to get back that there. If I go ahead and go to regexr.com, we can go ahead and see exactly what this looks like. I'll just grab this regex expression, come in here, paste this, and we can see if I were to go ahead and grab the example name here, we can see we grab space K. This isn't the most robust regex expression, but it's getting the job done. It's grabbing that grouping K, that letter K. All right, so then we're going to check if that letter, because we're getting that last name, this should be last name character, more specifically. We're checking to see if that last name character is equal to A as well. And if it is, then we're going to go ahead and count. So if we go ahead and run this, we can see we get back that there's no names in here that start with the letter A, but there is one last name that starts with the letter A. And if we can see, we can validate it. Yep, that seems to be working. We could even change it to another vowel that might pop up like O. If we do that, we can see we have one occurrence of one first name that starts with the letter O. Perfect. So it seems like our last transformation step is working. And this isn't the extent of transformations. Obviously, there are plenty of actions that can be taken during the transformation stages of a pipeline so that we can properly get our data into a nice state for anybody that might want to look at its final step or stage. We could also have added additional columns, putting the first name and last name into separate locations, creating a first column and a last name column. We could also have gone ahead and created some more complex regex expressions to really extract different values from this string that we have. So if the data isn't being downloaded or uploaded from somewhere within the ETL pipeline, it's likely going to be considered part of the transformation steps. So we didn't do any extraction, we didn't do any loading. This is all just transformation. Lovely. So let's go ahead and move on to the final step of the ETL pipeline, which is the load step. And what the load step is going to do is now that the data has been transformed to a point in which we are feeling comfortable with it, we can go ahead and move this data into a final location, a production grade location. Now, this is often the case after the extraction and transformation have taken place. We're going to want to put this data in somewhere that the data scientist, data analyst, financial analyst, or whoever needs to access it, including clients, can access it. So let's go ahead and load this data into a SQLite database. I'm going to go ahead and import SQLite 3. This is going to be our database management tool. And this is going to handle the setup of a relational database. And all a relational database is essentially a sort of tabular format for storing data in some type of column or manner, right? If you think of an Excel sheet, a pandas data frame, or just a general sort of table with columns and rows, that's what a relational database is. So we're going to go ahead and create one of those and store it in a database called astro.db. So I'm going to go ahead and connect to this database, and then I'm going to create a cursor, kind of like a mouse cursor, that's going to be able to interact with this database. So I'm going to go ahead and create that. And then after having set up the database connection and cursor, we can write a query to create the Astro table within the Astro, within the SQLite database, that Astro database, astro.db we've made up here. So I can go ahead and say create table Astros. And then I'm going to go ahead and specify some columns that I want to store this data in. So num and space, first name count, last name count, and timestamp. All of the different values that we made up here in our, oh, did I pass? Oh, yeah, right here, in our transformation steps, right? So I'm then going to go ahead and execute that on the table. I'm going to create this Astros table. And if I go ahead and run a query on it to get everything back, just saying select star from Astros. Go ahead and list this out. You can see we don't have anything in our database. Now, if I go ahead and insert that recently transformed data, that num and space, first name count, last name count, and now all data that we're getting from our transformation steps that we've already defined in our variables, these variables here, we can go ahead and insert those values into our Astros database. This is just going to grab num and space, put it here, first name count, put it here, last name count, put it here, and then grab the timestamp and put it here. And this is the same order that we have specified here as well. Num and space, first name count, last name count, timestamp. Num and space, first name count, last name now. Lovely. So if we go ahead and run this, we can go ahead and see we get back a cursor object, so it looks like it was successful. And then let's go ahead and print out what this list looks like. Oh, see, we have one data value, and it's the data that we have beforehand. Let's just go ahead and verify this. I'll come up here. and print out this timestamp, we can see it is exactly the same. So we see we've just uploaded and loaded our data into a relational database. Lovely. Now we can go ahead and move on to the next step, which is automating this. So we've gone through all of our stages in Etl Pipeline. All that's left is to automate the pipeline so that it can be ran on its own. Now, there's many ways to automate a pipeline. We could have this. We could have the pipeline triggered when new data is created to the source. So maybe when this JSON file updates, we can go ahead and listen for a change, and when it does, we trigger the pipeline. We could also automate it just by some type of timed trigger. So every couple of seconds or so, the pipeline will run. It could be every hour or so the pipeline will run. So there's different ways we can trigger this pipeline. And this is essentially the fourth hidden step of an ETL pipeline, automation. It's how do we automate the pipeline? And then again, this could be some type of time trigger, some type of data trigger, but whatever it might be, there's some type of automatic response that happens from some type of automatic event. So for instance, we can go ahead and just import time and say while true, go ahead and perform the extraction step, just getting that data from Open Notify. Then go ahead and grab the current time as well as the total number of astronauts in space, and then just get a running count of the total number of times that the first and last name start with the letter A. Then we can go ahead and we can then fill that data into using that insert data query that we have up here. Insert that data into our database every 2 seconds. So if we go ahead and run this, you can see it's going to continuously run. We can see it's running with a timestamp difference every 2 seconds. Cool, so we're adding data. We can see it's the same. I'd be very surprised if in some portion of time, a new astronaut were to fly to space and then, a new astronaut were to fly to space and or if they were to come down. I don't think that's very likely in 2-second intervals, but we can see that this is the process. And then this is just me printing out data added after the data's been added. Now if I go ahead and say select star from Astros, for some reason this is not running. Give it a moment. Go ahead and stop this. Seems to be taking a moment. Go ahead and run this again. There we go. Lovely. We got back all of our values that we just recently inserted with this automation step. Cool. So let's go ahead and move on to, after we just talked about ETL pipelines, let's move on to some other types of pipelines. So there's other types of pipelines, not with a fancy name like ETL pipelines, but other ideas behind pipelines and what they should look like. So one of the most common misunderstandings is the misunderstanding between data pipelines and ETL pipelines. So ETL pipelines and data pipelines are used interchangeably quite frequently, but they're actually referred to separate entities, separate ideas, separate theories. A data pipeline refers to the steps involved in moving data from the source system to the target system. And these steps include copying data, transferring it from an on-site location to the cloud, and combining it with other data sources. Now let's talk about the main fundamental difference between these two. An ETL pipeline includes a series of processes, series of steps that extract data from a source, so extraction, transform that extracted data, and then load it into some output destination. Hence the term ETL, right? ETL pipeline. And this is again in contrast to data pipelines, which a data pipeline is going to be a somewhat broader term that just includes ETL pipelines as a subset. It just refers to the set of processing tools that transfer data from one system to another. So when I was talking about data pipelines, literally a data pipeline is just moving data from point A to point B. There doesn't need to be transformation. You could have technically an EL pipeline, right? We don't need to load data specifically. We could just have an extraction and transformation step to generate some type of dashboard although there usually needs to be some type of load step when creating a dashboard. But these steps can be sort of used, or these extract, transform, and load steps can be dropped and changed as needed. We could also be generating our own data metrics and transforming data and creating data and then loading it somewhere else. So each one of these sort of letters in ETL is droppable to create some different sort of functionality for an ETL pipeline. And then these are all going to fall under the data pipeline because it's, again, moving data from point A to point B. So this brings us to batch and stream processing. Now, there are two ways we can process data. In isolation from any type of interaction from client, or in this instance, or in our instance, the API Open Notify, so it just sort of handles it on its own. As well as, again, so this is data being processed in batches from a sort of source database to some final destination. So again, this is such, so this batch data is handling intermittently. So for instance, we have one collection of data being passed to the pipeline, another collection of data being passed to the pipeline. So it's coming in sort of collections of data. So maybe we have 20 data points. That's the batch size. We have 20 data points being passed through this pipeline. Then we have another 20 data points being passed through this pipeline. Then another 20. So it comes in these batches. And this is in contrast to something like streaming data, which is continuously coming in different sizes and intervals. It's real-time data that users are going to interact with. And these interactions with this real-time data are called data streams. And this handling of the data is called handling streaming data. So in these cases, it's difficult to extract and transform data in large batches. When this data is coming in so frequently, we need to perform these transactions real time. So this leads to continuous flow of extracting, cleaning, transforming, and loading that happens very much in sync. So the batch data happens sort of in interval processes, while the streaming data in ETL pipelines is very much continuous. Data transformation is always happening. In batch data, it's happening intermittently. Right? Batch data might look like import or export integration, periodic recalculations of data, periodic operations. So periodic timestamp-based data usually deals with batches, while streaming data usually deals with stuff continuously changing, or some type of scalable data load, some type of scalable amount of data that's coming in. Right? So then this brings us to our final conversation of the day before I pass it back, which is going to be dealing with AWS, Amazon Web Services, which is a cloud platform. Now, Amazon Web Services can be a powerful tool in implementing these data pipelines we just talked about. They will provide us with many services, many cloud services that will allow us to sort of implement serverless technology to create an even more autonomous process. And it will also have the computing power at hand with their on-site servers, or offsite with our offsite servers, to deal with large amounts of data. So a lot of big data processes are handled entirely through AWS because of how much compute power they have on hand, right? AWS has a lot of servers opposed to me, who just has my MacBook right now, right? So let's go ahead and explore some case studies to see how AWS can be used to construct pipelines. So we can go ahead and, for instance, some of these terms aren't going to be well known, which is perfectly fine. Just know that a lot of this stuff is covered in the data engineering course. All of this stuff is actually covered in the data engineering course. So if you want a more hands-on approach, maybe consider signing up for the DE curriculum, since pipelines are usually more DE-centric stuff. But again, DS is going to be dealing with this machine learning step, which is also hosted on AWS as well, which you guys will be talking about in the DS curriculum. So let's go ahead and talk about one example of using a pipeline. So let's say an online order is placed. We can go ahead and immediately place that raw data, so that unchanged, untransformed data, into DynamoDB, which is just going to store that data in its raw format. Then this is going to trigger some type of event. This event is going to be handled, this triggering is going to be handled by Lambda. Then this is going to be transformed into a loaded state, so a Redshift database. So we have our extraction step, our transformation step, our load step, and our load step. So we can see this is just an ETL process, just behind the disguise of various AWS services. We can see analytics are generated from this data that is eventually cleaned to a point that analytics can be generated from it. Now, Alongside that as well, we have another process which is going to be dealing with streaming data. This is more batch oriented, as in user makes a purchase, that user goes to DynamoDB, that user is transferred or transformed, and then that user is placed. Here we have a bit more sort of streaming-based data pipeline where we have Kinesis handling real-time feeds of social media sites. And social media sites have a ton of data, and usually when you're dealing with social media applications, they have streaming data at hand. So when the streaming data comes in, Lambda again is going to be acting as the trigger for this autonomous process because of its serverlessness. And then it's going to be triggering a machine learning model, which is going to sort of run predictions off of that sort of stream that we have coming in, that stream of social media data. And it's going to then make a prediction and send those predictions to some type of customer support agent if it's matching some type of feed. So for instance, this pipeline here, let's say we are a customer and we're looking at specific, when we get mentions, we want to see if it's malice or not. We want to see if it has any sort of ill will against the company. So we can have a machine learning model, an NLP model, an NLP model, which is something you'll learn in the data science curriculum, a natural language processing model, which will look at this a social media feed, this text data, and if it looks malice, according to the machine learning model, it will send a message to the customer support agent. So this is 2 examples of how a pipeline is implemented on the cloud. And with that, I will go ahead and conclude my discussion on pipelines. We've talked about just general ideas of pipelines, the ETL process, how they're the most generic pipeline and mostly used, some other forms of pipelines and what they look like, and how the data that they have coming in can form their shape. And then we talked about how AWS can provide us with additional tools and additional methods for creating a more cloud-based pipeline structure. So I'll go ahead and hand it off to somebody.
Yes, thank you, Nick. That's so interesting. I will go ahead and reshare screen. We're going to go into questions in a few minutes, but before, Nick, do you mind unsharing your screen? Before we do, I will go through a few of our most commonly asked questions just to anticipate them a bit. So one of the questions we get asked quite a bit is if we have scholarships, and I'm happy to say that we do. We admit 2 types of students into both our data engineering and data science programs. One type is are the fellow students, and these attend tuition free. We offer a very limited number of these spots, each cohort to highly qualified candidates. Fellows are expected to leave any current employment and also interview exclusively with our hiring partners. The other type of student we admit are scholars, and scholars pay tuition to participate in the program, but they also have the benefit of being able to interview both with hiring partners and any other company that they wish, and they can retain their current employment. So scholars and fellows get access to the same curriculum, resources, and tools. And we only offer full tuition scholarships, the fellow spots, for folks who are enrolled in the full-time program. So it's not, if you're interested in part-time, unfortunately, you're not eligible for a fellow spot. We also have launched 2 additional scholarships for our data science and data engineering programs. These are the Women of Excellence in STEM Scholarship and the Equity and Diversity in Data Scholarship. And both of these are available for folks who want to attend the fall 2022 cohort. These aim to remove barriers and provide opportunity for women, veterans, LGBTQIA plus folks, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. Our scholarship applications are open. You can see the link here on the slide. And I would definitely encourage you to take a look at these and see if you qualify and apply if you do. Another question we get a lot is about employment rates after the program. So this is actually something we really pride ourselves on because we are really interested in helping students grasp data science concepts, but also transition into the field. So the data engineering program is still quite new, so we don't have full data for it, a full picture of how a placement is going for it quite yet. But what we can say for our data science program is that 97% of our graduates are working outside of academia, which is exciting. And also 88% of those graduates are working in data science within 6 months of completing the program. So that's pretty exciting. We're pretty proud of this. And again, we are really interested as a company to help people not only learn the information, but also transition into the field. So just to give you a sense of where our graduates are working and what they're doing now, what we can say is our graduates are working in 55 different industries. And some of the most common industries we see are computer science, computer software, internet, IT, financial services, and biotech. We also can say that, so it's the most typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. Titles and roles vary a lot depending on company and industry, but these are some of the roles we placed in the past. And I know I mentioned we don't have much data for our data engineering program yet, but you'll see that we have placed students in data engineering roles in the past. And actually, many of our current hiring partners are looking for data engineers. This is part of why I think it's a pretty exciting program. We've seen demand grow for this role 40% year over year. And just as a note, we also see our graduates are earning 16% more than industry standard, which is quite exciting to see. Here's a short list of some of our data science fellowship hiring partners. As I mentioned earlier, many of these companies are also looking for data engineering roles as well. Another question we get quite often is if we have financial assistance options, and luckily, again, the answer is yes. We have, in addition to our scholarships, we've partnered with LEAF to provide an income sharing agreement. This is a great option for a lot of folks. With this option, you attend the program just with deposit down, and you aren't required to make any payment until you've graduated from the program and are working and earning $40,000 annually. We also have a student loans available through Ascent. And with these, you have kind of 3 options for repayment: deferred repayment, where you don't make any payments during the program and for 3 months after; interest-only repayments, where you're making small interest-only payments during the program and 3 months after, and then you kick into full repayment; and finally, immediate repayment, where you begin making full payments 1 month after the program begins. For the Ascent loans, we have 36-month and 60-month terms available. And finally, for many in our part-time program, we found that companies are actually willing to sponsor or pay their employees to go through. Which is great because you get to learn and your company is supporting you. If this is something you think your company might be open to, but you need some information to present to them, you can definitely email admissions and we can share some of the information we have available for you to share with your employer. So where are we right now? Well, so we run multiple cohorts a year. Summer cohort is actually starting at the end of June, but currently we have applications open for the fall 2022 cohort. You can see some important dates here. The dates of the full cohort are from September, for fall, are for September 19th, to November 11th. And then the part-time cohort is from September 19th to February 3rd. If you are interested in applying, we ask that you submit your application by July 1st. And you will also have 72 hours to complete your coding challenge. This is 72 hours from the time you open it. The deadline to complete your coding challenge is July 4th. I will note that you can't complete your coding challenge until you've submitted your application. And just in general, I always recommend people try and do these in advance of the deadline, just because it gives you more flexibility if you run into any kind of technical problem or hiccup in your timeline. You'll have a lot more breathing room to contact us and have us help resolve it for you. So these are the dates for early admission. We also offer regular admission after our early admission cycle. The main difference, I would say, is that we do evaluate applicants on a first come, first served basis. So if you do want a better chance of getting a fellow spot, I would, or being selected for a scholarship, or just, knowing that you're accepted to the program, I do recommend applying for early admission. Another benefit actually is that we offer a priority enrollment package for early admission for all of our programs. And this includes access to a Python training course, which can be really helpful, early access to our career services support, which is, the resume writing piece, the cover letter piece, as well as a $2,000 off your tuition if you use direct payment. So that can be a real advantage. If you are interested in applying for the program, which I definitely hope you are, you can go to thedataincubator.com/apply and submit your application. Again, if you have any questions about your specific situation that you don't want to share here, or other questions about the presentation that you think of later, you can always email us at admissions@thedataincubator.com, and we'd be happy to answer them. And I think with that, we are ready to open it up to the Q&A. So let me just get this together. Okay, great. So this question looks like it's for you, Nick. Besides the ETL pipeline, what other sorts of pipelines do we have?
We talked about them previously. So we have the ETL pipeline, which comprises most pipelines just because of its general sort of generic form of extraction, transformation, and loading the data. But if we're talking about just data pipelines specifically, data pipelines in general are moving data from point A to point B. So just falling under the category of data pipelines, it doesn't leave us with a ton of options in terms of explanation. What we really have a lot of options in is what we do in that transformation step. And that's why ETL pipelines are so widespread, is because like they accomplish a lot of the things that we need to. Again, I mentioned beforehand that we could have an ET pipeline, we could have in TL pipeline, we could have just an extraction load pipeline. So those are different ideas and different pipelines that we might be able to implement. But what we really like to look at in terms of distinguishing different types of pipelines is the data that we have coming in. So is it batch data? Is it streaming data? What transformations do we want to impose on the data? Do we want a machine learning algorithm sort of dealing with the transformation of the data. So the transformation is really where a lot of the meat comes in. And then the loading and extraction, loading is a lot of where the data engineers come in too, to sort of design the databases and design the data storage units. So it really, these steps are very complex, and although it looks sort of simple from the example I gave, they actually are a lot more involved. And this is not a basic pipeline by far. It's very complicated in most cases.
Great, thank you. Another question for you, Nick. What kind of libraries would you use to prototype stream processing pipelines in Python?
I'm sorry, packages, is that what you said? Is that what the question was?
Stream processing pipeline?
Stream processing pipeline. So I'd use Kafka. Kafka is a good instance of when to use like a stream processing pipeline. So like, for instance, it'll handle the different streams of data that are coming in. Kinesis is one that I mentioned. It's more cloud-based. Kafka can be too if you host it on a cluster. So like there's Kafka, Kinesis. Those are very powerful tools that I usually end up falling back on. But yeah, I hope that answered your question.
Great. One more for you. Sorry.
No worries.
The AWS toolset, is the AWS toolset low or no code, or is it just a helpful visual for code that a data engineer writes and executes in the cloud?
Yeah, so there's a couple things. So usually it is pretty code intensive. So AWS, it's not just like a drag and drop thing. Usually we do need to perform some type of technical code writing to sort of get things up and running, especially if we're working with our own systems. If everything's living on AWS, it's a little less code involved. But if we say are grabbing our own, or we have our own data and we're moving it to AWS, then we're really going to have to actually start diving deep into the architecture that we want to have and developing that using our own code base. But as I mentioned, there's a couple ways we can interact with AWS. We can also use the management console, which is a bit less code hands-on, but it's still going to require you to write some code, especially if you're using something like Lambda or EMR or something that is doing some type of task. You're usually going to have to write that in code. But we usually can interact with AWS through Python with the SDK Boto 3, or we can use the CLI, which is just interacting with Amazon through the command line interface.
Great. So another question we got a few questions about our scholarships, which is great. So one question, are non-US residents eligible to apply for scholarships? I would encourage you to look at the specifics of the scholarship application, but I believe that if you are not a US citizen, but residing in the US, you are eligible for the scholarships. Another question about scholarships, it looks like both the scholarships mention women. Does that mean we can apply for both? I would say yes, you can apply for both. We will review applications and kind of determine who to give them to. I would definitely encourage you again to look at the overviews for each scholarship. The next question about scholarship again is, does the application discount stack with women in STEM? And yes, so the thing to note here though is that you only receive the early admission discount if you pay in full. So if you are using a financing option like the LEAF agreement or the Ascent loan, you do not get that $2,000 discount. It's only if you pay in full upfront. Great. Okay, one more question for you, Nick. Is AWS freely available, or is there a fee for individuals?
So starting out, they have a pretty nice, generous free tier for the first year that you sign up for AWS. So if you don't have an AWS account and you sign up for one, you should have a year of free tier usage, which gives you like free access to S3, EC2, and a bunch of other services. There should be, if you just look up AWS free tier, you should see all of the information you need regarding what it means to be in the free tiers.
Great. This is kind of our last call for questions. Again, we will be sending out the recording usually in a few business days. And if you have any questions that come up for you after this session, you can always email us at admissions@thedataincubator.com. And it looks like that's it. Thanks, everyone. Thank you, Nick, for such a great session. And we look forward to your applications. Again, feel free to reach out to us if questions come up.
Bye, guys.